So let's start our today's lecture. In previous lecture, we have seen uh, examples on repeated limits, and in this lecture, we are going to see the existence of simultaneous limit. So we are going to continue the part examples on limit and continuity. Continued part. So very first example. Yesterday we have seen how to evaluate repeated limit. Now in this example, so let us see example. Find repeated limits and simultaneous limit if exist for the function. Function is given f of xy is equal to y plus x into sine 1 upon y, provided this y is not equal to 0, because if y is 0, your function will not be defined. So first, for repeated limit. So first we will see the existence of repeated limits. So very first, take limit x tends to 0, then limit y tends to 0, your f of xy, and that is equal to outer limit as it is, limit x tends to 0, inner limit y tends to 0, put the given f of xy, that is y plus x sine 1 upon sine 1 upon y is there. It is sine 1 upon y, square bracket is there, and this is also there. So outer limit as it is, first evaluate the inner limit. So limit x tends to 0. Now this is limit y tends to 0, y plus x, it is sine 1 upon y, and I am going to adjust here 1 upon y. So here divide and multiply it by 1 upon y. So at the numerator you will get 1 upon y as it is. So you will get this limit is 1, and what is that? So it is limit x tends to 0, and if you put limit as y tends to 0, so this limit become 1, and this is 0, and x into 1 upon uh, y is there. So again you have to adjust here. So limit x tends to 0, limit y tends to 0, y plus x upon y. So it is 0 by 0 form. So it is limit x tends to 0, limit y tends to 0, y square plus x upon y. So it is 0 by 0 form. So in the first year we have seen L'Hospital's rule. So limit limit outer limit is limit x tends to 0. So it is 2y plus 0 upon, you are differentiating with respect to y numerator, and this is 1, and finally you will get 0 upon 1 is 0. So the first repeated limit is 0. Let us see the next repeated limit. Next is limit y tends to 0 outer, limit x tends to 0, f of xy is limit y tends to 0, inner limit x tends to 0, your function is y plus x sine 1 upon y. So this bracket you have to simplify first. So this is limit y tends to 0. So you will get, you have to take limit as x tends to 0. Now this is constant and x 0 into constant is 0. So it is simply y and it is y, and therefore two repeated limits exist and these are equal because value of the limit is 0. Now two repeated limit exists, but still we cannot conclude the existence of simultaneous limit. So for existence of simultaneous limit. So here in fact by observation we show that limit simultaneous limit is limit xy tends to 0 0 f of xy is your y plus x sine 1 upon y, and that is equal to 0. So we use epsilon delta definition of limit. So when we say that we say that I am just recalling the definition. We say that limit xy tends to 0 0 f of xy is L if for given epsilon greater than 0 you can find a delta greater, there is a delta greater than 0 such that what is that mod of f of xy minus L is strictly less than epsilon whenever condition is that whenever mod of x minus 0 is strictly less than delta mod of y minus b. So a and b are here 0. So mod x is less than delta, mod y is less than delta. So this is the definition of limit, and we are going to apply this limit to show that limit xy tends to 0 0 f of xy equal to 0. So very first let epsilon greater than 0 be given. What is L here? L is equal to 0. So consider which mod of f of xy minus L. So let us see what is this. So mod of f of xy is, what is the f of xy? It is y plus x sine 1 upon y minus L is 0. So first simplify this. So it is simply mod of y plus x sine 1 upon y. So mod x plus y is less equal mod x plus mod y, triangle inequality. So this is less equal mod y plus mod of x sine 1 upon y. Again this is less equal mod y plus mod x. Reason is that since mod of sine theta is less equal 1 for every real number theta, and what we have written here, since by triangle inequality. So triangle inequality is mod of a plus b is less equal mod a plus mod b. Again here mod ab is mod a into mod b, but mod of sine theta is less equal 1. So you can directly say that mod of f of xy minus L is less equal mod y plus mod x. We know that for every real number x and y we have, what is that, mod x is less equal square root of x square plus y square, and mod y is also less equal square root of x square plus y square, and therefore you can say that mod x plus mod y is less equal to square root of x square plus y square. Now if this quantity becomes less than epsilon, so if 2 square root of x square plus y square becomes less than epsilon, that is which quantity? So that x square plus y square strictly less than epsilon by 2, then so whatever this quantity is there, you have to choose that is equal to delta. Likewise, we have did this in first year to show that limit of function of one variable is equal to L. So here we are going to show limit of function of two variables. So choose which delta. So whatever that last term is there. So this term is nothing but your delta. So choose delta is equal to epsilon by 2, and obviously that becomes 0 because your epsilon is strictly greater than 0, and therefore for this delta we have obviously mod x is less than delta and mod y is less than delta, and mod of you must have f of xy minus 0 is strictly less than epsilon. Thus we have, why I have written this, see in the previous, if this quantity is less than epsilon, then you can say that mod of f of xy minus L is strictly less than epsilon. But what is this quantity? This quantity is nothing but 2 square root of x square plus y square. Means if you get square root of x square plus y square is strictly less than epsilon, then directly you can say that this is strictly less than epsilon. And if you choose epsilon is delta is equal to this term epsilon by 2, then for this delta obviously, so you are, this quantity is strictly less than epsilon by 2, and this quantity is also strictly less than epsilon by 2, and if you choose this epsilon by 2 is equal to delta, so directly you can say that mod x is strictly less than delta, again mod y is strictly less than delta. I am going to erase this we don't need here, and therefore we have what we have for epsilon greater than 0, there exists delta is equal to epsilon by 2 greater than 0, such that, what is that? Mod of f of xy minus L is strictly L is 0, so mod of f of xy minus 0 is there, is strictly less than epsilon whenever mod x is less than delta, mod y is less than delta. Mod x is less than delta means mod of x minus 0 is less than delta, and therefore by definition of limit we have, or you can say that limit, simultaneous limit xy tends to 0 0, f of xy is equal to 0. What is your f of xy? So directly you can write limit xy tends to 0 0. What is f of xy? It is y plus x sine 1 upon x, and limit of this function is equal to 0, and thus in this problem simultaneous limit exists and is equal to what? It is equal to 0. So this is the criteria to show that simultaneous limit exists. How to show that? So I will just recall this. So this is about the definition, epsilon delta definition. So we have taken epsilon greater than 0, and what is limit, value of limit, L is your 0. You have to consider mod of f of xy minus L. Whatever f of xy is given, so put here minus L is given 0. So simplify this, and you want this RHS term strictly less than epsilon. So use this criteria. Obviously, for every real number, you must have mod x is less equal square root of x square plus y square, and mod y is also less equal square root of x square plus y square. And from that, find out what is square root of x square plus y square, and that is strictly less than epsilon by 2. And whatever this RHS number, you have to choose that is equal to delta, and care should be taken that delta must be strictly greater than 0. So choose delta equal to epsilon by 2, and that is strictly greater than 0. And for this delta, you must have mod x is less than delta, mod y is less than delta, and you will get mod of f of xy minus 0 is strictly less than epsilon. Means what? For given epsilon greater than 0, we have a delta. What is the value of delta? Delta is epsilon by 2, and that is greater than 0, such that mod of f of xy minus 0 is strictly less than epsilon whenever this mod of x is less than delta and mod y is less than delta. So our conclusion is that limit xy tends to 0, 0, y plus x sine 1 upon, I have written here by mistake 1 upon x is there, but here you must have sine 1 upon y is equal to 0. That is simultaneous limit exists and is equal to 0. Now next example. Next example is that using definition of limit, prove that limit xy tends to 0, 0, your function is square root of mod of xy, and that is equal to 0. So we don't need repeated limit, but if you want, you can compute repeated limit, and in both way you will get it is equal to 0. So let f of xy is, your function is square root of mod xy. Obviously L is given. So to show that limit xy tends to 0, 0, f of xy equal to 0, what we do? We use epsilon delta definition. So let epsilon greater than 0 be given. So I am not going to write the definition epsilon delta definition. In the previous example I have written, so you have to keep in mind that definition. So consider what we have to consider, mod of f of xy minus L. So what is mod of f of xy? Here is square root of mod xy, and minus L is 0. So it is simply mod of square root of mod xy. So obviously mod of mod is again positive, so it is simply square root of mod xy, because in real numbers square root is always positive. So this is straight mod, and now what we want here? So we want this quantity, but just split mod AB is mod A into mod B. So this is square root of mod x into mod y, and again this is your square root of mod x into square root of mod y. So I have just simplified this mod of f of xy minus L. Now we want this quantity is strictly less than epsilon. So next, we know that general result. What is that? Obviously, mod x is less equal square root of mod x, and that is obviously, sorry, I have written reverse definition. Square root is always less equal, so it is square root of mod x is less equal mod x, and that is less equal square root of x square plus y square. And similarly, square root of mod y is less equal mod y, and that is less equal square root of x square plus y square. And therefore into this, so you will get therefore square root of mod x into square root of mod y is less equal x square plus y square. In the previous, we are going to see what is mod of f of xy minus L is square root of mod x into square root of mod y. So next page. So square root of mod x, and now we want this quantity is strictly less than epsilon. So if x square plus y square is strictly less than epsilon, that is if you take under root, because we want a circular neighborhood. So if this quantity square root of x square plus y square is strictly less than root epsilon, choose delta is equal to square root of epsilon, and that is greater than 0. And now if you choose delta equal to this, so this quantity becomes less than delta. Yes, this quantity becomes less than delta, this quantity becomes less than delta, but I am not going to write here. Therefore for this delta we have what we have, mod of f of xy minus 0 is strictly less than epsilon whenever the quantity is that mod x is strictly less than delta, mod y is strictly less than delta. And therefore by definition of limit, what is that? Limit, simultaneous limit xy tends to 0 0, f of xy equal to 0. What is your f of xy? That is limit xy tends to 0 0, f of xy is square root of mod xy, and that is equal to 0. So we have used epsilon delta definition of this limit to show that limit exists. So this we have done this problem here. In some example, it is quite difficult to use epsilon delta definition. So, but we have to show that the limit exists. So, what we have to do in that type of example? So, you have to use polar coordinates. So, let us see limit using polar coordinates. So as compared to Cartesian coordinate, limit using polar coordinate is easy to handle. So sometimes, so we know that polar coordinates are x equal to r cos theta and y is equal to r sin theta, and therefore as xy tends to 0 0, we get now variable xy becomes r theta. So you will get r theta tends to 0 0. So let us see how to solve these limits using polar coordinates. So limit using polar coordinates. I'm not going to write here. Yeah, sometimes it is difficult to evaluate limits using Cartesian coordinate, and therefore we use polar coordinates. And in fact, if you further observe, because you can use this criteria, mod of sine theta is less equal 1 for every theta, and mod of cos theta is less equal 1 for every theta, and that is equivalent to limit r tends to 0 f of r cos theta r sin theta. So simplify this, you will get limit xy tends to 0 0 f of xy. So let us see an example. Using polar coordinates. Using polar coordinates, prove that limit xy tends to 0 0 x cube upon x square plus y square, and that is equal to 0. So we have polar coordinates. So very first write down what are the polar coordinates. So x equal to r cos theta and y is equal to r sin theta, and therefore f of xy becomes your x is r cos theta bracket cube upon x square is r cos theta bracket square plus r sin theta bracket square. First simplify this. So you will get it is r cube cos cube theta upon r square is common, and cos square theta plus sin square theta is 1. So it is simply r cos cube theta, and therefore limit xy tends to 0 0, your f of xy becomes limit as r tends to 0 0 f of r cos theta and r sin theta. So instead you just apply the polar coordinates. So limit r tends to, so what is your f of r cos theta r sin theta? It is r cos cube theta. It is simply r cos cube theta. Again, this is less equal limit r tends to 0 if you take absolute value. So it is cos cube theta, and this quantity you know that mod cos cube theta is less equal cos theta its cube, and that is less equal 1 cube, and that is 1. So which is less equal limit r tends to 0 mod r, and that is equal to 0, and thus you must have limit xy tends to 0 0. What is your f of xy? So it is directly 0, and therefore, so see, there is no epsilon, no delta. Still you have proved that the simultaneous limit is equal to 0. So remember, to show that the simultaneous limit exists, you should always use epsilon delta definition in terms of Cartesian coordinate. But if you don't want to apply the epsilon delta definition, so you are free to use polar coordinates. So remember polar coordinates, x equal to r cos theta, y equal to r sin theta. Then first given function you have to express it as f of r cos theta and r sin theta. So wherever x is there, you have to replace x by r cos theta and y by r sin theta. Simplify this and then apply the definition of limit. Limit xy tends to 0 0. F of xy becomes simply limit r tends to 0 whatever function in terms of r and theta, and apply this and you will get, simplify this, you will get the answer is equal to 0. So you will observe that as compared to epsilon delta, this polar coordinate method is easy. So now I am going to give you some exercises. So exercise number 1. So using polar coordinates, I am going to give you exercise. सर माझं लेक्चर चालू आहे, थांबावं लागेल. Using polar coordinates, prove that limit xy tends to 0 0 x cube into y cube upon x square plus y square equal to 0. This type of example we have covered in the just now. So go through this and you will get the answer is 0. Example number 2. Using definition of limit, prove that limit xy tends to 1 to function is x square plus 3y, and this value of limit must be 7. And exercise number 3. One more example is for practice. Examine whether limit exists or not. If exists, find it. For the function limit xy tends to 0 0, your function is x square minus y square upon x square plus y square. So y square, that plane is with here, so x square plus y square. So first check for repeated limit, and if repeated limit exists, then go to simultaneous limit. And very first, if your repeated limit does not exist, so you conclude that simultaneous limit does not exist. So this is all about the existence of limit of function of two variable. In next lecture, we will see continuity of function of two variable. So let us stop here.